Yeah, today I'm just interested. Starting from today, I'm just interested to discuss about a few more, lead code questions on a daily basis, whether it's lead code or any other DSA problems as well. This is just a starting point, and we're just going to try and work this together, think this together, and just implement it. I'm going to use C language. Right over here, we are beginning with a very easy problem. We notice that we have been given an array of integers named as nums, as we notice right over here, and it's a pointer, of course, and an integer target which is available right over here. I mean, from this very at this specific moment, what I would probably talk about or think is how they have named it, which gives me a clear idea that it has something to do with the target without even reading the rest of what's given. Moving forward, we just have to return indices of two numbers such that they add up to the target that's provided right over here, meaning the indices of course, the nums array that's provided. We may have to assume each input would have exactly one solution, pretty convenient, and you may not use the same element twice. You can just return the answer in any order. Well, they're just given a few examples, as simple as it can get. 7 and 2, and target seems to be 9. So 0 and 1 seems to be the position, so on and so forth. But what strikes my eye first would be the returned array must be malloc right over here. And that's what we're going to start with. Meaning, I'm just going to create a pointer and work with malloc. I'm pretty sure if you're going to use malloc, it assumes the data type to be void, which is why we're explicitly working and pushing it towards an integer to, sorry, a pointer to an integer. So now I can use malloc, which is going to store two numbers, meaning I don't need anything more than two specifics, meaning about 8 bytes on an average. It need not be the same. That's why we are going to multiply with size of int and not assume the number of bytes. It could be more than 4, depending on whatever, so many circumstances. Moving forward, I do notice that we may just have to, compare each and every element, add it, move on. So I'm just going to use two different for loops and work with that particular indices it provides. It's going to be less than num's size, meaning it's the size that's provided with regards to the nums array. So I don't have to even find it, but of course it's easier to even find. And that's exactly what I've done. If I'm going to use these two arrays, it's going to check every single element one by one. So let's take this particular input as example. Starting with 2, we're going to check 2 plus 7, 2 plus 11, 2 plus 15. If none of these work, we'll pick 7, 7 plus 11, 7 plus 15, so on and so on and so on. That's how this is going to work. But the problem is, we may not use the same element twice. But if I use I and j being the exact same in dice, meaning we're just comparing 2 and 2, which is not allowed right over here. Meaning, we start with I, but it has to be at least one more position with what's available. So if it's 2, we move on to 7. If it's 7, it's 11, and conveniently, that's how it's going to work. Well, we just have to return the indices, meaning I just have to check it. So at I plus j, these indices, if these guys equal to the target, my job is done. So I'm just going to decide by the precedence explicitly without letting it happen in its own way. Not that it will not occur, but I've usually learned that the code must work solely because we chose it, even though things may happen, not even in this case. But moving forward, if the statement is true, we're just going to declare it, meaning at the position, let's say 0, we can practically implement. It doesn't matter if even if I implement j or I, so it doesn't matter. I'm just going to give anything. And that's practically it. We do also notice that there is a return size, and I've just used a malloc array right over here, meaning I have to return that particular array and its size, meaning I'll have to access the value of return size, and we just use 2 being 0 and 1 indices, which is it's just 2 elements, so that's just 2, and we return what's available as the array itself practically. But there are cases where it could fail this entire notion, and then we'll have to assume that the return size has to be 0 because we have nothing to provide with. And the flip side is we just have to return null because there's nothing to do with. This should practically work if I'm not wrong. Let's just try and check if things are fine. Well, what's the error? Oh God, sorry, we haven't declared, of course. Okay, smaller mistakes. I think these are the moments where I understand, because I think I try to largely focus on the logic. Uh, These are moments where I realize it matters too much to notice every single dot, but it's kind of exciting to move on. Right over here, we do notice that the code works, but there's a long way to go. Of, at times, the same exact solution, if we submit twice or more, it seems to move up in the ladder in terms of time, space, complexity, but I think we could work towards a better solution. This is just a small starting point. We'll try to move on to the next. I'm also interested to take a look at a few solutions, whatever that's worked the best. Well, why not? Everything leads to a hash map. Regardless, we'll try another easy question. I think I've already done it if I'm not wrong. So why don't we do it together? This is it. Right over here, I'll take a note. It's again easy as a starting point. We are meant to solve it, to think together. So, longest common prefix. Write a function, that's what we're working with over here, to find the longest common prefix string amongst an array of strings. If there is no common prefix, we return an empty string. We have a few examples to help us with. This is an array of strings as they have given over here. That's why they've used a double pointer. And every single one of these strings hold fl as its prefix, as we do notice. I think more than that, that's why the output seems to be fl. Right over here, of course, no common elements. So we'll have to return exactly whatever this is. There are a few constraints. Yeah, it's going to be just lowercase. Yep, it's not empty. Well, one of the first cases that comes to my mind is if at all the size seems to be 0, meaning there could be test cases where there is nothing to work with. So there's practically nothing we could return, meaning we could return what they've asked right over here and stop with it. If I'm not wrong, that is. This is one thing that I notice. The second would be to work with the string itself. My logic, or what I'm going to try, is have this particular or the very first string as my reference point and compare every single element of this particular string with the following strings. At some point it will stop, and whenever it stops we're going to return whatever is available towards the left hand side. So I'm picking the indice, so I being 0, I less than, because I'm picking the indice, I'm just going to make sure that at the position that we're talking about, it shouldn't be equal to the null pointer of the particular string that we're working with, whatever that is. Of course, it's a 2D array and we're working with the very first string. It's going to be at the position 0. Moving forward, of course, I increment the I. That's where we go. Right over here we can consider declaring a character in order to appoint one single element. So 0 will lead us to the first string. The second implementation is just I, meaning we are accessing every single element of the first string. Moving forward, while this is true, what we can do is create another loop and check certain things. Let's say I'll just start with 0. We're going to reference every single string within the array of strings, so we'll have to get right up there. So we'll have to compare things, but instead of trying to find cases where it passes or it's positive, we'll have to find cases where it fails. Well, if at all the case that we're talking about fails, meaning if at the position of j and the element that's available at the position I, if this is not equal to character C, we may have a trouble. By 0 we are accessing right the strings exactly. I'm not talking about 0, sorry. By using j we are accessing the strings within the array of strings, and by I we are accessing the exact same position of indice we are referencing with the very first string present in the array, which is convenient. Well, there could be another test case where we do notice that the flow right over here will have a null pointer arriving at it as much faster than the other two guys. So that process should end there when it's a null pointer, meaning whatever we are accessing at this position, if it's just a null pointer, we'll have to end our operation. So if it's equal to just the null pointer, we just have to return whatever is available. We don't need to declare a few things, collect the elements, whatever. What we can probably, a little creative thing would be to just use the same array. At the exact same position where it stops is where we'll have to induce a null pointer, meaning it allows the compiler to understand the fact that that's where it will have to stop reading. That's where things are right in our understanding, and that's what we want to return. So we'll just return that particular array that we worked with so far. Yeah, that should practically be it, if I'm not wrong. Let's just declare a few things and check a few test cases. Of course, there might be mistakes. Yeah, I think I and J, I don't think I've declared anything. Yeah, character C. Okay. Okay. Maybe we'll have to try another edge case that we might have missed. If at all these two cases skip past, we'll still have to provide reference, meaning why don't we just return? Okay, my understanding from this looped for loop or a nested for loop would be that we're testing cases where it will fail but will return. Got it? What about the cases that it misses and moves on? Yeah, I think we're missing one more test case, which is where all of these possibilities could be true. We haven't addressed it, meaning every single string within the array of strings could be the same string, meaning it could be just, let's say, a flower followed by a flower being the other string as well. So every single test case for that particular string passes out, and we don't address that over here, is what I'm assuming to be the case. So we might have to just return the entire first array. Not array, sorry, a string. Let's just check if that's true. Seems to work. Why don't we check and submit it? Yeah, that checks out. I do understand. It seems clumsy. We're talking a lot. Doesn't make sense at times. A little bit of missing out on logic and indentation, or even declaration. But that's how I want the process to be. And that's how I think it'll benefit all of us. And that's how I learn with my friends or personally. It kind of gives me a confidence. Maybe I'm not doing the best, but I think this is how it'll work out moving forward. Yeah. Thank you.